Okay, this is a combinatorics problem. It's about my 532 LTB collection. You see the picture in the corner, and I might have mentioned this before. So 532 LTB. This is what we have to choose from. Now, if you're my friend and I might be so kind to lend you 3 of them. So how many options would you have to pick 3? Very straightforward question. It is 532, choose 3, right? You would evaluate this the following way. 532 times 531 times 530 all over 3 times 2 times 1. You can always cancel everything in the denominator. Here you get 265. If you cancel 3 here, we get 9. This is indeed divisible by 3. So this is 177 actually. And now I would just type that in, or I might have also used the NCR command, and we get 24,953,460. Okay, that's the number of ways in which I can pick 3 out of the 532 LTBs. The formula we used is n choose k. It's the formula you use if you have to choose. Okay, it's n choose k. You choose without repetition. There is no replacement. You cannot pick the same book twice, and your order is not relevant. It doesn't matter whether you first pick 41 and then 28 or the other way around. Next, down here you see my 3 favorite books. Number 1, my all-time favorite is 41, where Donald becomes Phantomias. Then the runner-up, probably 28. I just like the Dagobert figure. And then, say, 3rd place, maybe 181. Der Traum vom Big Brother. It's actually sort of Disney's adaptation of 1984. And I really liked 1984 when I read it. At grammar school, actually. So, in how many ways could I have chosen my favorite 3 books? Well, the problem sounds very similar, but it's not quite the same. The point, of course, being that the order is irrelevant. Here it does matter whether 41 comes first and then 28 or the other way around. Now, there are several ways to look at this. Perhaps the most straightforward way is to say, for the very first book, I have 532 options, for the next one 531, and then for the 3rd place 530. So this is what I need to compute. I can type that in directly and I get 149,720,760. Okay, here it's again without replacement. It doesn't make sense to pick the same book twice or thrice, but order is relevant. The formula we had for this is n factorial over n minus k factorial. You could also write this as k factorial times n choose k. I boxed this formula because that's the one we had on the theory handout. I mean, it's just a 6-fold. All we need to do is we need to pick 3, what we did in the first subproblem, and then we have to introduce the order, which means multiplying by k factorial by 3 factorial, in this case by 6. Okay, here the formula in the box is actually, if you sort of complete these factorials, then you notice that this is 532 factorial all over 529 factorial. It's just a concise way to write this, even if the product contains many factors. Okay, that's the 2 first very basic cases. Now let's have a look at the more interesting problem. My more interesting problem is a variation of the first one. You may choose any number of LTB to borrow them, okay? Earlier I said 3, borrow 3. Now I say borrow any number you want to. Well, you have more options now, because you don't have to take 3, you can also take 0. You can answer to this proposal saying, well, you know, I'm not really into LTB, okay, alright, you can pick none. Or you can be very nice and just say, okay, 1 will do, thank you very much, and so on. Of course, you can pick the 3 from before, and you can pick many more, and you can be as bold as saying, well, okay, you said I can pick as many as I want to, so give them all to me. Okay, that's what we need to compute. Now this is very tedious to type in, that's not really an option. The point is, we have to look at this differently. We have to change our perspective. What we actually do, if the question is this general, is we look at each single LTB and decide for everyone whether we pick it or not. Okay? So it's sort of asking a yes or no question 532 times. Now order does matter, because it is relevant whether we pick book 41 or 28. And we have 2 options each. So one way to solve that more easily is, do we pick number 1, yes or no? We have 2 options. Do we pick number 2? Do we pick number 3? Etc. Do we pick number 532? And this really should be the same, should it not? This is 5 2 to the power of 532. What a nice equation here, okay? This long sum of all binomial coefficients is equal to this power of 2. This was an example of using n to the k. We have n options each and repeat the choice k times. Okay, here we have with replacement, because we can say yes more than once, okay? So the question, of course, remaining is, what is this equal to? 2 to the 532. If you use your calculator, you're disappointed because it is not able to evaluate such large numbers. I use this as a refresher for the following. If we call this figure n, then the logarithm in base 10 of n is the logarithm in base 10 of 2 to the 532, which can be rewritten. This is the logarithm law you really should try to memorize, okay? It is the most important logarithm law. I'll now stop writing down the base of the logarithm. It is always going to be 10, okay? We can type this in. 532 times the logarithm of 2. This is not hard for our calculator. It tells us it's 160.148. Now if this is the logarithm of n, then we can go back and say, well, then n of course is 10 to the power of 160.148. And we can even split this. This is 1 to the 160 plus 0.148, which is equal to 10 to the 160 times 10 to the 0.148. And again, we've got something that our calculator can easily compute, and we find that n is approximately 1.4, that's the 10 to the 0.148, times 10 to the 160. Okay, and we have the number of options in scientific notation. All right. Now this was just on a sidetrack, okay? This is how you compute large numbers, large powers, using your calculator. Now, you might have noticed that I am really boring because I lined them all up in order. Of course, that's actually a good idea, because then we all see these pictures that we get if we have all of them. But there would be other options to arrange them, right? How many options are there to put them in a line? This is the last formula I want to show you. For the first place in my shelf, I have 532 options to choose from. Then I made my choice. So for the second place in my shelf, there are 531 LTBs remaining, and so on down to the very last one, when only one option remains. This, of course, is 532 factorial. You could say this is a special case of choosing my top 3. And I agree, but this putting something into an order is so important that this should really come without thinking, which is why I emphasize this as n factorial, as sort of one rule you should really know by heart, okay? So the last question now being, what is 532 factorial? And I'll show this in the second part of the video.